Hi guys, this is Virendra. Today I'm going to talk about anagram substring search. So the problem statement is given two strings, pattern and text. We need to find out whether any anagram of the string pattern is a substring of the text. For example, if you have an input text like IDeserve and pattern like veer, you want to find out if any anagram of veer is a substring of IDeserve. Okay, so what is anagram? Anagram is basically any permutation of a given string. So let's see if there is a permutation of this pattern part of this text. Okay, yes there is, and we output true for that. ERVE is the permutation of veer that is part of IDeserve. I would suggest that before going to the algorithm insights, please pause the video and try to come up with a solution yourself and then come back and continue the video. Okay, so let's go to the algorithm insights. So in this we have the string IDeserve, the text and the pattern. I have split them into characters and put them in character arrays. Okay, so this is the pattern and this is the input string. What I'm going to do is I'm going to maintain two hash tables. One is called pattern hash, the other one is called text hash. In the pattern hash I'm going to put the characters in the pattern and the corresponding number of characters that are present in the pattern. So for example, if you have veer as the pattern, so the pattern hash will have v, 1, e, 2 and r, 1. Okay, so the number of characters in that particular pattern. Similarly for text hash. Now to understand how we are going to populate these hashes, I'm going to move this pattern along the text. So let's see how that will be done. We'll first look at these four characters, the first four characters of the text. We'll populate those in the text hash and then populate the pattern as well. And then we'll compare the pattern and text hash and see if both the hashes match. If they do, then we have our answer, right? If it is true. If they do not, we move forward. So we move forward the pattern along the text. Okay, and then again we recompute the text hash. We don't have to recompute the pattern hash because we have already done at the first substring. Once we have the text and the pattern hash updated, we compare them again and see if they match. If they do not, we move forward. Likewise we do till the end of the string, and finally we'll find anagram of the pattern as the substring of the text. Okay, so let's do this step by step. Let's start from the first character. Let's populate the pattern and text hash simultaneously. So we have v and I, so we populate v, 1, I, 1. Go ahead, we populate d, 1, e, 1, right? And then we update e here in the pattern hash because we have two e characters, so we update it as e, 2, and then we go ahead and populate e in text hash as well because we have e in the text, the substring of the text. Okay, so we are looking at only IDES, only the four characters. Okay, and then we go forward and update s and r in the hashes. Finally we have the pattern and text hash of length 4, and then we compare. Are they equal? No, right? The hashes are different. So we go one by one in the keys and see if the counts of characters match, and the characters, if the characters match, we have to see the counts of characters match. Okay, none of the characters match, so definitely the hashes don't match. We move forward. One trick here is when we move forward to the next substring, we just delete the first character of the previous substring from the hash and add the last character of the next substring in the hash. Okay, so here we have e as the next character. Since we have all the other characters already in the hash, we don't have to go and traverse the whole substring again. Okay, so we just delete the first character of the previous substring and add the last character of the next substring in the text hash. So we have found e here, which is a new character in the new substring at the end of the substring. We update e in the text hash, and this is what we get. We have two e characters in the new substring, which is DESE. Okay, now we have the text and the pattern hash populated. We compare. What do we find? We find that they do not match, right? So we go forward. Again, what we do is we remove the first character of the previous substring, right? We remove D and add the last character of the next substring. We add R. Then we have both the pattern and text hashes. So we compare both of them and we find that they do not match. Let's go to the last substring, which is of length 4, and try to populate the text and the pattern hashes. Here at this point, S was the first character of the previous substring. So we are going to remove that, and we are going to add the last character of the substring that is into consideration. Okay, so what do we have here? E comma 2. Now we compare the text and the pattern hash. We find that both of them match, right? So definitely there is an anagram of the pattern as a substring of the given input text. Okay, that is how we do it. The code for this solution is uploaded at GitHub. The link is right here in this annotation. Please go ahead and look at the code and let me know if you have any doubts and comments. Thank you for watching the video. Please stay tuned. We are uploading more and more videos as and when possible. Please do check out our website at www.ideserve.co.in. We have close to 200 articles there, and we also invite you to contribute to the website. Please email us at ideserve.co.in@gmail.com. Thank you.